Welcome to question 7, CSEC Math Exam, January 2012 video solution. Now in this question 7, we are given a histogram representing the distribution of height of seedlings in a sample. Now in part A, we are given this table to complete using information from the histogram. And what we see here are the classes. So there are 1, 2, 3, 4, 5 groups or 5 classes. The height in the first class, for example, is 1 to 10, second class 11 to 20, third class 21 to 30, fourth class 31 to 40, and the fifth and final class is 41 to 50. And then we are given the class midpoints. We are given 2 of the class midpoint values, and then we are given 2 of the frequency values, and we are asked to complete the table. We're going to use the histogram to help us to complete the table. Now if you notice on the histogram, the bars of the histogram are touching each other at the boundary values of the classes. So for example, the lower boundary value of the first class will be 0.5, hence this first bar is at 0.5. And then the upper boundary value of this first class is the same as the lower boundary value of this second class. So it's 10.5 upper boundary value here and 10.5 lower boundary value here. So hence this boundary is shared by the first class and the second class, and that is the trend throughout. Alright, and then now the frequency values would be obtained by reading from the frequency axis here. To the top of this bar is the frequency for the first class, which is 18. The top of this bar is 25, corresponding to here, and we can go through and find the other bars. Now the class midpoint for the groups are calculated using the average of the boundary values, because the midpoint would correspond to the midpoint of the bars from lower boundary value to upper boundary value, and hence the midpoint will be halfway between those boundary values. And so the midpoint is calculated using the average of the boundary values for each class. Alright, so let's show, for example, how we would calculate the midpoint for this third class, 21 to 30. It would be the average of the boundary values, right? And that's it. The lower boundary value, which is 20.5, plus the upper boundary value, which is 30.5, sum of those divided by 2. That's the definition of how you would calculate the midpoint for this class, and that value would be 25.5. Now the difference between the first midpoint and the second midpoint is 10, and that would be the difference between all the midpoints. So we can basically add 10 to find the subsequent midpoint, but if we were to show calculation for the midpoint values, this is what it would be. Alright, so we can add 10 for the subsequent midpoint. So this is 25.5 for the midpoint of this class, and then we can add 10 to get the other 2. So those are the midpoint. Now for the frequency, as I said, we have to read the frequency from the top of the bars of the histogram, and those will correspond to the frequency values on this vertical axis. So we can go ahead and put those values in. So that's 18 for the first group, 25 with the frequency for the second group. Based on the graph, this one would be 23. That's for the third group. And then for the fourth group or the fourth class, it will be 20. That will be the frequency. And from here, we can read that it will be 14. So we read these frequency values from this histogram, and so we can now complete the table. So it's 23 for the third class or third group, 20 for the fourth group, and 14 for the final group. So that's the table completed. That's the solution for question 7a. Now let's move down to 7b. Now in 7b, the first question is asking us for the modal class interval. The modal class interval. Now what is the modal class interval? The modal class is the class which has the highest frequency, and it corresponds to the tallest or highest bar on the histogram. Now that's this bar, and that corresponds to the second group, which is 11 to 20. 11 to 20 centimeters is the modal class because it carries the highest frequency and it is the tallest of the bars on the histogram. So this is our modal class, 11 to 20 centimeters. So we can go ahead and put that in. 11 to 20 centimeters is our modal class interval. Now, what if the question had asked us to find the mode? The mode would be situated in the modal class in this second class, but we would have to construct the boundary diagonals at the top of the modal class to find the intersection where the mode is located. Now let's show that construction. So we would have to construct from here to here. That's the boundary diagonal. This one, that's the first one. And then the second one would be from here to here, right? So it's from here to here, and then from here to here. So the intersection of those two boundary diagonals at the top of the modal class corresponds to the position of the mode. So we would construct down to our horizontal axis to find the mode. And based on this construction, the mode would be 18 centimeters, and that would have been the mode, 18 centimeters. The question did not ask us for the mode, but if they did ask for the mode, that is how we would have to construct it. The boundary diagonals at the top of the modal class, we'd have to draw those in to intersect, and then the point of intersection, we find the value on the score axis, which is horizontal axis, and that in this case would be 18 centimeters. So the mode, an estimation of the mode would be 18 centimeters. But in any case, the modal class is a class with the highest frequency, and that one corresponds to a frequency of 25, and that class is our 11 to 20 centimeters class interval. And that's the answer for the first part of question 7b. Now the second part is asking us for the number of seedlings. Now this table is showing us that there are 18 seedlings in this class, 25 seedlings in this second class, 23 seedlings in this third class, 20 other seedlings in this fourth class, and 14 seedlings in this class. So basically the number of seedlings will be the sum of our frequency, right? So the sum of our frequency is our number of seedlings. The total number of seedlings in the sample is the sum of our frequency, and the sum of these frequency values is 100. And so our number of seedlings is 100, right? And then part 3 now is asking us for the mean height of the seedlings, the mean height. Now, in a grouped frequency distribution, as we have here, where the scores are grouped, we have to estimate the mean. There are several ways of estimating the mean, but for the CSEC syllabus, we estimate the mean using the class midpoint. What you do is assume that all 18 seedlings in the first group have a height that is equal to the midpoint of the first group. So the midpoint of the first group is being used to represent the first group. The midpoint of the second group is being used to represent the second group. The midpoint of the third group is used to represent the third group, and so on and so forth. So we're assuming that there are 18 seedlings, each having a height of 5.5 centimeters in the first group. There are 25 seedlings, each with height 15.5 centimeters. There are 23 seedlings, each with height 25.5 centimeters. There are 20 seedlings of 35.5 centimeters. and there are 14 seedlings, each of height 45.5 centimeters. That's how we estimate the height. And then what we want is the sum of all those heights divided by the number of seedlings. So we need to put in a column where we calculate the sum of the heights in this first group, the sum of the heights in this second group, and so forth, right? And so the formula for the mean would be the sum of the frequency times the x, the midpoint value, divided by the number of terms, the number of seedlings, which is the sum of the frequency. So we see we need a column where we can calculate our frequency multiplied by x, which is our midpoint values. Right? So we need that column. So you put that column in, and then we do the calculations for each group. Right? So 18 multiplied by 5.5 is 99. 25 multiplied by 15.5 is this value here. And then 23 multiplied by 25.5. And then 20 multiplied by 35.5 gives us 710. And then 14 multiplied by 45.5 giving us 675. And then we will take the total, that's the sum of our f multiplied by x. Basically what this represents is the height, the sum of the height of all the seedlings, all 100 seedlings. And then the sum of the height of all 100 seedlings divided by 100 will give us the average height or the mean height of the seedlings. So then based on this table, the mean height would be 2,420 divided by 100, and so the mean height is estimated to be 24.2 centimeters. That's the mean height of the seedlings, and that's the answer for part 3. Now part 4 of question 7b is asking us to calculate the probability of randomly selecting a seedling that has a height that is greater than 30 centimeters. Now, which of the groups have seedlings of height greater than 30 centimeters? This group is from 31 to 40, and this group is from 41 to 50. So these two groups would have seedlings that are greater than 30 centimeters in height. And so there are 20 seedlings in this group and 14 seedlings in this group. So the total number of seedlings out of the 100 with height that are greater than 30 centimeters would be 20 plus 14, that's 34. So 34 of the 100 seedlings would have heights greater than 30 centimeters. And so that probability would be 20 plus 14 divided by 100. That's 34 out of the 100 seedlings would have a height greater than 30 centimeters. And that probability reduces to 17 out of 50. So that's the probability of randomly selecting a seedling that has a height of greater than 30 centimeters. 17 divided by 50. And that's the answer for that part of the question. And that's the answer for question 7. Right, so in our next video, we'll do question 8. All right, see you then.